3. 2, 3. Any others? So starting with number 2, evaluating. We are given some expressions where m is equal to -7 and n is equal to 2. We're going to put both of those values in. So 4 times -7 minus 2, and simplify. So do what's on the inside first. Use your PEMDAS, FEMDAS, STEMS, whatever you were taught. So order of operations, do what's on the inside first. -7 minus 2. Then you can't do anything else. The absolute value signs make it positive because it's really measuring distance. And then multiply those two together. So your final answer would be 36. Questions on that one? And then domain is something, I know it was covered in Algebra 1, whether you remember that or not is okay. So domain is all of your x values, so you're looking furthest left to furthest right to figure out what your domain is. So when you look at this has arrows to mean it's going to keep going up and left, slightly left, off the grid, off the page, forever and ever in that direction. And then the same thing for the other way, up and slightly right, off the grid, off the page, forever and ever in that direction. And because it keeps going slightly left and slightly right in both directions, your domain in words would be all real numbers from -infinity to infinity. So when we did interval notation for our inequalities, that would be -infinity to infinity. When you were first taught this, it was a different notation, so I'm going to write both, but either answer would be fine. So the first one is our interval notation from -infinity to infinity. The second one means the same thing, but it's read as x such that x is an element of all real numbers, which is really means from -infinity to +infinity. Questions on that? So before we get into our inverse lesson, I want to give you time to practice. So this will start before lunch, and then we'll do a little bit more after lunch, and then we'll start our inverse. So I'm going to give you about 20 minutes to do one of the following. In your direct variation notes at the very end, there are practice problems. It says homework. You can be working on these problems in the practice. Numbers 1, 3, 6, 9, 12, 13, and then on the very last page in the word problems, numbers 4 and 5. Do as many of those as you can. In this next 20 minutes / when we get back, also part of the 20 minutes. Or you can be working on the 2 Khan Academy quizzes that are due today if you have not already done those. So you must be working on one of these 2 things, either the Khan Academy that's due today or this practice problem, not doing other things. Anyone have any questions on that? Okay, so it is 10:33. We go to lunch at 43, so we'll do 10 minutes now and then 10 minutes when we get back. So at lunch, we'll stop and then come back and do another 10 minutes. Everyone should have these notes. What you'll notice as we start doing the inverse is that they have a lot of similarities to direct. There are just some differences as well. So in inverse, I'm going to be comparing them a lot. Where direct had a constant ratio. Inverse has a constant product. The direct variation equation was y equals kx. The inverse variation equation is y equals k over x. When we were finding our constant k for direct, it was k equals y over x. For inverse, to find k, it's y times x. And just like the direct, that really stems from or comes from the original equation. So if you forgot how to find k, you could look at the original, think about how we would get k by itself. We would need to get rid of x. So we could multiply it on both sides. And whether you write it as x times y or y times x, it doesn't matter because multiplication is commutative. So let's use that information to find our k value. Starting with number 1, if we are multiplying y and x together, multiply 1 and 20, 2 and 10, and 4 and 5, and see what that value is. Just like direct, your k value has to be the same for all of them. If it's not, then it's not your k value. And once you find that k value, you can write it as an equation. So using our y equals k over x, this would be y equals 20 over x. Questions on that one? This works the same way in ordered pairs and in the table. So if we were looking at number 3 and we were multiplying our x's and y's together, someone multiply negative 5 and 2.4, tell me what you get. Negative 12. And as we're multiplying all of them together, we get the same number, negative 12. So that would be our k value. So our equation would be y equals negative 12 over x. Do we have questions on either of those? So this next part, I'm going to show you how to graph it, but you're not going to need to know how to graph it. You're just going to need to know what it looks like, and the best way for us to do that is if we just graph it. So in this example, they tell us we have a constant of 16. That means our k value is 16. To figure out how to graph this, think about what times what would give us 16. Okay, 4 times 4. What else? 8 times 2. What else? Yeah. And then because we're going to be graphing these, we can also say the flipped version of these, so 2 and 8 and 1 and 16, even though they still give us the same thing. So we're going to graph these. This graph is counting by 2, so be careful. So 4, 4, we're going to plot a point there. 8, 2, 16, 1, 2, 8, and 1, 16. And it'll look kind of curved. Connect those dots. When we found the numbers that multiply to be 16, we only focus on the positives, but a negative times a negative is also a positive. So we're going to change these numbers to be negative as well. Negative 1 and negative 16, negative 2 and negative 8, negative 4 and negative 4, negative 8, negative 2, negative 16, negative 1. And graph those as well. Negative 1, negative 16, negative 2, negative 8, negative 4, negative 4. So it kind of makes that same curve, but now it's like flipped. And you can connect those, draw lines through them. This would be your inverse variation graph. So if you're asked, is this inverse variation or not, you could graph it and see, does it look like this or not? If it looks like this, then yes. If it's a line, just a straight line, diagonal, vertical, horizontal, it's definitely not curved, so no. If it looks anything that doesn't look like this, then you could say no. So you just need to be able to know and recognize what it looks like. So when you're asked, are these inverse variations or not, you can figure that out. Questions on what that looks like? Again, you will not need to be able to graph it by hand, I should say. You could put it in your calculator. If no questions, move on to the next page after you finish graphing that. Okay. And then we're going to do a couple of these, or a few of these examples. Starting with number 7. What's nice about these is that the process we use for direct is the same here. Find your k, put it into your equation, solve. It's just how we do it is a little bit different. So right here are 2 equations on here so you remember them and don't have to flip back. Y equals k over x and k equals y times x. And then for number 7, find your k value first. Multiply 12 and 14. Someone multiply that. Tell me what you get.
1.
Okay. After you find your k value, take your inverse variation equation, y equals k over x, and put that in. Then look at the other ordered pair, see what you have and what you're missing. We have x, we don't have y. Put that value in for x.
No, this is not.
Whoever, someone else just said.
You said it. You said it. I never said it. This is
I'm not doing it.
Okay. Anyway, divide that. Someone tell me what that is. -7. And then the check process is the same. If we took -7 and multiplied it by -24, we should get positive 168. So we know that is our right answer. So I should say similar, not the exact same. I'll write that off this one. Okay, this is good. Questions on that one before we move on? Move on to number 10. Look at the numbers that you have together, so 21 and -3. We multiply those together. What is that? -63. Put that into your equation. Y equals -63 over x. And then look at what you're given, what you're missing. Here we don't know x, but we know y. How would we solve for x? So when we multiply the x, it just moves it to the other side. We have -7x equals -63. And then divide both sides by -7. What you could also do is cross multiply, then you wouldn't be doing this twice. And then to check yourself, you could multiply 9 and -7, which is -63, so you know that would work. Questions on that one? Let's do a couple of the ones with words. Remember that the process is the same, even though it has words. So with 11, we have y equals 9, x equals -6. Multiply those together to find your k. After you have your k, put it into your equation. So y equals -54 over x. Here, again, we're trying to find x. So we know y is 3. So we would be, if we cross multiplied like I was saying earlier. We know that 3 is really over 1. And if I cross multiply, we have -54 and 3x. I guess it wouldn't matter. You still have to divide it then. So disregard it then. Either or is what I meant them. You can multiply or cross multiply. What would our x value be? Negative 18. And 3 times negative 18 is negative 54, so we know that works. Questions on that one? We'll do one more of these before we move on to word problems. 14. So if y is negative 8 and x is negative 7, multiply those together to find your k value. Take that value, put it in your equation, y equals 56 over x. Then look and see what you have and what you're missing. Now we need to find y when x is negative 4. Divide that and tell me what your y value is. Negative 4. And negative 4 times negative 14 gives us a positive 56, so that works. The biggest thing with these is keeping the equations straight, not mixing them up, and then just making sure that you're doing the right thing for both. But once you know how to do both, the process is really the same. Go on to the word problems page. We'll do a few of these. And then any questions you guys want to see, and then you have time to practice. So let's start at number 7. I'm sorry. You guys have something I don't. The little thing that's up here, whatever yours says. When do we use inverse? So it's opposite of direct. It either goes up, one goes up and the other goes down, or one goes down and the other goes up. So examples of that are like, I'll just use these examples. The faster you drive to travel somewhere, thank you. The less time it takes to get there, and vice versa. Trying to think of some other example. I had one earlier and I lost it. Whatever they are, they're opposite. So they're not going up and down together, basically. With these examples, whatever comes first is still your y, so that part has not changed. And then whatever comes after is still your x. Here it'll say words like varies inversely, inversely proportional, things like that. So, and then also label them or write it off to the side what each thing means. So your y would be your time, x would be your average speed, look at what you're given. So if a train travels between 2 cities in 3 hours, that would be your time, your y. At an average speed of 65 miles per hour, your x. Use that to find your k value. Multiply them together. what would that give us? $195, okay. Then use that, put it into your equation. Y equals 195 over x. Just like direct, the hardest part about your word problems is knowing what you're solving for. So in the question it says, how long would it take at an average speed of 78 miles per hour? So are we looking for x or y? We're looking for y, and we're given x. So put in the number you know for x. Divide that, and figure out how long it would take. What would our y value be? 2.5, and 2.5 what? Hours. And if we multiply 2.5 by 78, we would get 195, so we know that works. Questions on that one? Let's do another. For number 8, a company that produces laptops has determined the number of laptops it can sell varies inversely to the price. So that means number would be our y, price would be our x. Then they say 2,000 laptops, so this is talking about number of, that's our y, can be sold when the price is 2,500. Use those numbers to find your k value. It's going to be a big number. Multiply that, someone tell me what you get. Yeah, as we said, it's going to be a really big number. So put that into your equation. Y equals 5 million over x. Then the question says, how many laptops can be sold if the price of the laptop is 1,000? So are we looking for y or x? Y again. So put in the 1,000 for x. And figure out how many laptops we have. Should be 5,000. And then 5,000 laptops. You're more likely going to get bigger numbers with inverse than direct, because direct is dividing for the most part instead of multiplying. Yes and no. You might get big numbers for the k value here, but maybe not. It depends. Okay. Questions on 8? Alright, let's do one more. And then any other questions you need to go over, and then we'll be done. So number 11. The time it takes to bake a turkey varies inversely with the oven temperature. Which is y, which is x? Time is y. If it takes 3 hours to bake a turkey at 300 degrees, so 3 hours is our y, 300 degrees is x. Multiply those to find your k value. Here, since it asks us to find the constant of variation, 900 would be our answer. Look through the problems we didn't do. See if there are any that you have questions on, want to see, go over, clarify, anything like that. If not, for the rest of the class, it is yours to practice. So you can go through any questions we did not do, problems on the last practice pages, as well as Khan Academy that is due next week. We are going to draw names today.